Climate change. It's complicated, which is why we debated it for a couple decades and wanted to actually make sure it was humans that were the problem and not natural things like volcanoes and the sun. But we know that humans play a huge role, and you can see directly coming out of human activities in more than one place is CO2, greenhouse gases. Okay, that can affect our troposphere, but the one that jumps out at me is right in the middle. Everything is connected to global moisture. Warm air holds more moisture. So when we heat up the atmosphere, we are changing the water cycle. And the water cycle touches just about everything in the ground, in the air, on the surface. That's the big deal. Everything is connected. Okay, so what does that mean on a global scale? Well, we can actually start to screw up these natural global wind patterns. The Hadley cell, where hot air rises at the equators and it moves out, and about 30 degrees it descends, pressure changes, and that's why we get deserts like the Sahara. We are altering that. By putting more moisture in the air, we are extending some of these arid regions. And then that is a cascading effect up and down the latitudes. By changing the amount of moisture in the air, we are actually altering the global circulation patterns of the atmosphere. And then because everything interacts surface to air to ground, we're screwing up the convection, the heating and cooling that's happening in the ocean. There's this big global belt called the thermohaline conveyor belt. Thermohaline. Thermo means temp. Haline means salt, the ocean water, salty water. Thermohaline belt. We know that when we heat up different parts of the Pacific, we can actually reverse the entire current. And that is what we call an El Nino. In the Midwest, we get wetter winters. Other parts of the world go through extreme drought that aren't used to it. And that's the real problem. It causes extremes. It makes storms stronger. It makes droughts longer and more severe. It's the extremes that are threatening our lives. The main point of this is that it's all connected. We change one thing, we change it all. Not just here in the US, but everywhere. I already said that warmer air holds more moisture. If the ocean heats up, hurricanes thrive on that. We start to see bigger storm seasons. What was that, 3-4 years ago? We ran out of names. We use a list each year. It's got an alphabetical list of names. There's about 20 names they use each year. We ran out, so they started using Greek letters. Hurricane Alpha, Hurricane Beta. And so these storms are bigger, more frequent. And then remember, in a hurricane, you may not know this, but it's not actually the winds or the rain that's the huge problem. A hurricane is a giant low pressure storm. And it's the lowest pressures in the world, right in the middle of the eye. Well, if you have low pressure, that allows the ocean to rise because there's not as much air pushing down on it. So the ocean rises up and the wind pushes all that water on shore. It's called a storm surge. People who live on the coast, that's why those beach houses are built up on stilts. When the storm surge comes in, that's what kills and does the most damage. So we're seeing bigger storm surges than we've ever seen before. As I said, the opposite is true, the extremes. We're seeing droughts, which are threatening soil quality, nutrient cycling. Or if we're getting too much rain, that causes too much soil erosion. All right, I alluded to this last week, but what's really happening, and the reason that climatologists say we're at a point of no return, we're going to get to a spot where we can't slow it down anymore. We are in what is called a positive feedback loop, which you can see results in exponential growth. So temperatures go up. That melts ice, which exposes the darker soil underneath, which then absorbs more heat. We lower the albedo, how much gets reflected back to space. And all of those bottom three there, result in temperatures going up even more. which speeds up the melting of the ice, which results in more heat. And it is a never ending loop. We have to break it somewhere. We have to figure out a way to slow the rising temperatures or the speed that the ice is melting. You see, this is happening in places we don't even live. We don't live in Antarctica. We don't live up in the Arctic Circle. But our actions at the lower latitudes, because of global wind patterns, are affecting the poles. Climate change is more noticeable there than it is here. And you know how humans are. If we don't see it in our daily lives, we don't worry about it. But in other parts of the world, it's happening in ways that are tangibly visible. We're melting in places like Canada and Russia, Siberia. We're melting permafrost. And what's trapped in there is a whole bunch of carbon. As this permafrost melts, we think by 2100, we could see 40% of it gone. It's releasing methane. And we know that methane is a more powerful greenhouse gas, higher GWP than carbon dioxide. As the sea ice melts, that contributes to ocean rise. And this is another one where we looked at, the temperature has been going up over the years. And I told you, check the scale, because it's only going up, fractions of a degree each year. But that adds up over time. The same thing is true about rising sea level. You can see since 1990, really going back to mid-1980s, it's rising at about 3 millimeters a year. But look at the slope of the line. We have sped it up. By 1930, we see another kick in the average, and then we've sped it up again since the mid-80s. That's population growth. That's fossil fuels and bigger population. It's a demographic transition. These guys are losing habitat, which is threatening them as a species. We are finally seeing it in beach towns, places all up and down the coast. Here's Charleston, South Carolina. They're going to spend $2 billion to build a seawall and try to hold back the rising ocean from destroying their historic downtown. You know where I'd put the $2 billion? Reducing fossil fuel usage, alternative energy. We're just slapping a Band-Aid on it if we build a wall. Remember, humans are just a piece of an ecosystem, and there are some things that could potentially benefit from a warmer Earth and from more aquatic ecosystems. Some animals are going to have new habitat. Talk about putting a positive spin on global flooding. And we could see changes to what we call the photic zone. Remember, that's how far light can penetrate down into the water.